Hi folks, today we're looking at the properties of polynomial functions. In our last class we looked at an investigation into polynomials and got some ideas of how their end behavior worked. We had a dance around how you can figure out the end behavior of a polynomial. And we looked at how many x-intercepts they might have and how factored form might help us out. So over the course of this chapter we'll learn how to graph those complicated polynomials and how to factor them. But to start with, we should probably define what a polynomial is. A polynomial is a function that has whole number powers on its x's. So it could take the form a x to the n. So a is a coefficient plus b to some one less power. Now if this were a quadratic, the n would be 2, so it would be a x squared, b x to the 1, and then you'd have another number tacked onto the end. We typically use, if it's a quadratic, the letter c to represent that last number. But polynomials can have higher degrees than just 2. So they could be an x to the 99, and then you'd have an x to the 98 term, and an x to the 97. And that can go on indefinitely. And then at the end, there's going to be some constant. We can use the letter k for it, though that doesn't mean that we've gone a, b, c, d, e, f, g, h, I, j, k and stopped there. We're just saying that there's a constant at the end. Okay, and it's where n is a whole number. So that's the set of numbers 0, 1, 2, 3, all the way up to infinity. But no fractional powers, no negative powers. The degree is the highest power on x. So in a polynomial, that's going to be the n from this form. And the domain of a polynomial is always all real numbers. If polynomials were an ice cream flavor, they would be vanilla. They are functions that behave really nicely. They're always smooth. They exist everywhere. They're pretty predictable. Now, I know some people like to have pretty complete notes, so these are your 3.1 notes. You might want to pause this and take these down in your notebook. The next thing we'll do is look at some common polynomial types. So degree is the highest power that's on x. So here are some that we've run into before. If you have a degree 0 polynomial, that would mean you'd have y equals a x to the 0. Okay, or you just have a constant. We could think of it as just y is the constant in that case. Let me get rid of this and write that in. If it's degree 0, you won't see the x at all. So y is a constant. That is the equation of a horizontal line. So any degree 0 polynomial is a special case. It's a horizontal line. Super boring. All right, degree 1. This would be, you'd have an a x to the 1, and then you'd have your constant on the end. Now, I don't really need to show that x to the 1, so let me just rewrite this. Degree 1 is going to be y equals ax plus k. You're looking at that and probably thinking, hold on, we've used different letters for this. This here is a linear function because x is only to the power of 1. And every degree 1 polynomial, will be a linear function. It will be a diagonal line. We could also think of it with the letters that we've used from grade 10. So the letters that we use are totally arbitrary. But in either form, this first coefficient gives us slope, and this second coefficient gives us the y-intercept. All right, let's do a degree 2 one. So degree 2 would be, you'd have an ax squared plus bx plus a number on the end. You can call it k for the constant. You can call it c if you prefer. It doesn't matter what letter we give it. Right? It takes this form if it's a degree 2 polynomial. And we learned some things from that type of polynomial. We know that its shape is a parabola or quadratic. This was the type that we dealt with the most in grade 11. And we know a few things from this form. We know that if A is positive, it tells us the direction of opening. If A is positive, it would open up. Also out of this, we'd get that the last letter, whether we call it C or K, is the Y-intercept. Because to find a Y-intercept, you just put in 0 for x, and all you'd be left with is that number at the end. So let's do a little catalog of things we've noticed so far. The number at the end here seems to always be the Y-intercept. From our investigation the other day, the leading coefficient, this A that's up front, seemed to determine the end behavior, whether it went from up to down or down to up. And the degree determined kind of the overall shape. So these are all the polynomials that we have dealt with so far. We want to generalize and come up with rules that are going to work for all polynomials, degree 3, degree 4, degree 5, degree a million, whatever. That brings us to this slide that I call polynomial gold. So here's just a general polynomial. I don't know what degree it is, depends what n is. But no matter what the degree is, it's going to have a coefficient in front of its first term. And if you don't see a coefficient, then the coefficient's just 1. A is called the leading coefficient. So as usual, we have excellent words for stuff in mathematics. The first coefficient that you see is the leading coefficient. And it is the most important coefficient. It determines what the function does in the end. So it controls the end behavior of the function. And that means the far left and far right behavior. K is the constant term. It's always just going to give us our Y-intercept. All right, so that kind of brings us back to our investigation the other day, and maybe even to the polynomial dance, which we'll revisit in a minute. But if n is odd, so if the degree of the function is odd, whether it's cubic or power of 5, here's what it does. It's going to come from below, rise. It'll have maybe some turning points. I don't know how many. I'm just going to say it does some stuff in the middle. And then in the end, it will go up. An odd function will do that if A is positive, okay, or if the leading coefficient is positive. If n is odd, which means it's a degree 3, 5, 7, or 9 function, or any odd number. If A is negative, here's what happens. It comes from above. It can do a bunch of stuff in the middle. I don't know how many turns we'll have here. But in the end, it will go down. So if we only think about far right, if A is positive, it will go up to the far right. If A is negative, it will go down to the far right. And between that and our dance, we probably know the general look of any odd polynomial, odd degree polynomial. All right, let's check out for if n is even. You actually know this one maybe a little better. If A is positive, for a parabola, if A is positive, then it's one that opens up. For a general polynomial that might have more turning points than that, any even degree polynomial will go from up, so it started high. It'll have a bunch of turning points maybe in the end, but then it will go up again. So I don't really care what happens in the middle, but the end behavior is up to up if it's an even degree and A is positive. If the leading coefficient is negative, that gives us a function. Think about it as a parabola. It would go from down to down, or we'd say it opens down. So if it's any even degree polynomial with a negative leading coefficient, it's going to go from down to down. Those are the basics of polynomial properties for n behavior. Maybe we'll summarize them with an easy way to memorize them in just a second. So let me show you how you can memorize the end behavior of even and odd degree polynomials. Now we've already done the dance, so we know that it's got some degree is odd, looks like this, or degree is even. But I want to take the dance and bump it up a level in terms of what it's going to mean to you. And in order to do that, what I learned from choreography from my daughters is that really I have to be facing in the same direction that you're going to be. So I'm going to turn around here, but hopefully my voice will carry. All right. So first I'm going to do like this with my right hand up. Degree is odd. That's what a positive leading coefficient odd graph looks like. It goes from down all the way to up. So right hand up, degree is odd. The next one I'll show is still degree odd, but negative leading coefficient. So it goes from up to down. So for the degree odd, here's positive, here's negative. Now degree even, this one I could do facing you. So here's positive, degree is even, here's negative, degree is even. So if I go through the dance, which we know at this point is like this, like this, like this, like this. We're thinking Silento's watch me as we do this, right? Oh, watch me with. Okay, so that wouldn't make as good choreography, but degree is odd, degree is even. Degree is odd and positive, then odd and negative. Degree is even and positive, even and negative. So it always starts with the positive. Degree is odd and positive, odd and negative. Even and positive, even and negative. So degree is odd, degree is even. Degree is odd, degree is even. And that's how we can keep it straight. So remember, they start with the positive for each of those. That is a little more of my pride that you get for today, Internet. Congratulations. Hope that you folks are doing well. Let me know if you have questions.